Alright, this one has a lot going on and stuff we've learned in the past. First thing, we need to know, I guess I should get a pen color here. We need, it wants to know work. So I'm just going to kind of come down here and say A, work equals force times distance. Well, I'm not going to do force first, but I'm going to do distance. Back in the day, we did velocity equals distance over time, which turns into distance equals velocity times time. I have a velocity of 1 meter per second, and I have a time of 3 seconds. Seconds goes away. It's 3 meters. So right away, I know I'm going 3 meters. I don't know why I put a dot there. 3 meters. Now I have to do force. The force, since it's not accelerating, the force that you're pushing it, the force applied, since it's not accelerating, it's a steady speed, minus the force of friction equals 0. So the force applied equals the force of friction. We have an equation for force of friction. It equals the mu, my mu got a little carried away there, mu times force normal. The mu is 0.660. Force normal, since it's on a horizontal table, it is the weight of the block, and weight is mass times gravity, so it's 10 kilograms times 9.8 meters per second squared. So that's going to be my force of friction, and let me grab a calculator. Alright, I'm back. I'm going to punch all this stuff in my calculator. 0.6 multiplied by 10 multiplied by 9.8, and I'm going to get 58.8 newtons. That comes up here. 58.8 newtons. It's already in my calculator. I'll multiply that by 3. And I'm going to get 176.4 joules. Now this next part, part B, says what is your power output? So power equals work divided by time. We just did work of 176.4 joules, and my time was 3 seconds. That number's already in my calculator, divided by 3. And I get kind of like that number we just did before, right? 58.8 watts. Woo woo, woo woo.